All right, so multiplying binomials. First off, someone tell me what a binomial is. What's a binomial? Okay, it's not an equation of two what? Terms. There we go. Terms. I heard it there. We have two terms in it. All right. We have polynomial is a name for, an expression that has variables and numbers and a couple different terms. Okay. A binomial is a special type where there's only two different terms to it. So if I'm multiplying binomials, I'm going to have a binomial, a two-term, times a two-term. Okay. We distributed a binomial to a binomial on Tuesday. Now we're going to have two things multiplied. It's going to look something like this. What do you think of when you see this? What'd you say? Foil. Okay? All it is foiling. Multiplying binomials is just foiling. First, outside, inside, last. We did this last chapter, right? Remember I told you last chapter when we did the FOIL, I was introducing it early for you. Now we were going to see it again. This is the day when we see it again. Okay, so first, outside, inside, last. We'll do some practice of these, and I'm not going to keep repeating it over and over again because we already did this somewhere. All right, so this guy here, I have to FOIL this. So I start with first. First, going to be 4x times 3x. Multiply those, what do you get? 12x the second. Outside, 4x times 3 is what? Just 12x. Inside, negative 2 times 3x. Negative 6x. Negative 2 times 3 is negative 6. Now, is there anything else I can do to this? Get this and this are like terms. So I have 12x squared. And then what? Plus 6x minus 6. Now, is that written in proper polynomial form? Yes, it is. Okay, it's written in proper polynomial form because I have my powers of my exponents from biggest on the left to smallest on the right. It goes 2, 1, 0. Okay? Now, what type of polynomial would that be now? Trinomial. And it's the power of 2, so it is a quadratic. That'd be a quadratic trinomial. All right? Just for some review here. All right? You guys do this guy. Follow that one. Make sure it's in proper order. You can. You don't have to. Okay, we're going to get somebody doing on the board for us. That somebody's going to be Foster. You better finish it up real quick because you're up. Well, let's go. You can finish it on the board. There's an N with that 24. You gotta combine like terms now. You don't have to break it down at all. The first N should be N squared. 2N times 4N is 8N squared. There you go. Add the two middle ones. Just the two middle ones. 10 and 24. That's it. Negative 14. And then you still have the 8 squared out to the left. Left. The other left. Okay. So we multiply the outsides. Multiply 2N and 4N, you get 8N squared. Multiply 2N and 5, you get 10M. Inside, negative 6 and 4N is going to be negative 24N. Negative 6 and 5 is going to be negative 30. All right, then you combine your like terms, you get 8N squared minus 14N minus 30. How many people got that? All right, good deal. All right, I'm going to write up 4 of them now. Give you guys a few minutes to try them. Yes. Okay, there you go. On the first one, multiply the outside. We have 2x times 3x is 6x squared. Good. 2x times 5 is 10x. And negative 3 times 3x is negative 9x. Negative 3 times 5 is negative 15. So the first one, we combine like terms in the middle. 6x squared plus x minus 15 for number 1. Looks good. Number 2, multiply 6x and the x to get 6x squared. 6x and negative 5 is negative 30x. 3 and x is 3x. 3 and negative 5 is negative 15. Combine the like terms in the middle. Is 6x squared minus 27x minus 15. By that one. Number 3, outsides. 5s and s is 5s squared. 5s and 3 is 15s. 2 and s is 2s. 2 and 3 is 6. Good. Combine the like terms in the middle. 5s squared plus 17s plus 6. Good. All right, now the last one's a little bit trickier because there is an x squared in the first set. So I multiply through. I have 8x squared times 4x, which is going to be 8 times 4 is what?
32.
32. X to the third. And then this times this is going to be 80x squared minus 2x to the fourth minus 2 times 4 is 8x. Negative 2 and 10 is negative 20. Now, do we have any like terms there? No, we don't. All right, be careful here. The next squared, this is an x. We cannot combine those. Okay, just be careful. I think if you see in the pattern, if there's no squares in them, if it's like an x and a whole number, x and a whole number, what do? You end up combining the middle two, right? That's pretty consistent. And you're going to find out when we get to Friday, we're going to do it in the opposite direction. So on Friday, you're going to be given something like 6x squared plus x minus 15, and then we're going to have to work backwards to get it back to this parentheses. Okay? Well, maybe not with a 6. So we'll start out with one like this, just x squared plus x minus 15, something like that. We'll work backwards. We'll start small, work our way up. All right, now, one little thing if I want to throw in here. What if I would do a binomial times a trinomial? It's a little different. So if I have this, let's go x plus 2 times 2x squared minus 3x plus 4. That really doesn't fit FOIL anymore, does it? No, it doesn't, does it? Because now I have more terms. FOIL only technically works for if you have 2 terms and 2 terms. This one I have 2 then 3. All right, we still have to take the same concept. If you want to look at it a different way, this is just going to be double distribution. All right, so in FOIL, what do? Multiply the first set of parentheses, each term by each term in the second, correct? So in this guy, we would go here to here, here to here, here to here, and here, here, and here. Okay, so nothing really changes. Just the word FOIL, the acronym doesn't hold anymore. All right, so x and 2x squared is what? 2x to the third. X and negative 3x. 3x squared. X and 4. 4x. 2 and 2x squared. 4x squared. 2 and negative 3x. Negative 6x. 2 and 4. 8. Okay, now we go through here. We have a couple sets of like terms. Here and here. Here and here. All right. So 2x to the third. X squared. So I got a negative 3 and a positive 4. So what's that going to be? Plus x squared. 4x and negative 6x is what? Negative 2x, and then I just have the plus 8 at the end. Questions on that? It's not horrible, is it? Okay, you guys do this guy. got what you need. All right, so while she's combining like terms, all right, you have to distribute the 2x through to everything. So 2x and x squared is going to be 2x to the third. 2x and 5x is 10x squared. 2x and negative 3 is negative 6x. And distribute the negative 3 through everything. So negative 3 times x squared is negative 3x squared. Negative 3 times 5x is negative 15x. And then negative 3 times negative 3 is positive 9. Good. And then we can combine like terms. We only have 1 cubed. Squares. We're going to have 10x squared. Negative 3x squared. So this should be plus 7x squared. A little out of order here too. So you multiplied it well. All right, so then we have our 2x cubed, right? All right, then squares. We have 10x squared and negative 3x squared. Should be plus 7x squared. All right, and then an x and an x, negative 6 and negative 15. There's your negative 21x. And then lastly, we just have our positive, which is 9. So we just messed up a little bit here on, if you have a wrong, this should be a squared here. And that needs to go together. All right, but then we end up with 2x to the third plus 7x squared minus 21x plus 9. All right, questions? How many people got that answer right? All right, I think we're pretty decent with this stuff, right? So we've already done it before. This is just review. All right, so now we have a couple special cases we want to look at. This is 8.4. Again, it's not real crazy. It's just 2 little rules. All right, and these are 2 rules. If you forget them, you can just FOIL. It doesn't really matter. All right. First one is the square of a binomial. So I'm going to put the rule up first. A plus B quantity squared. Okay, if you have a set of parentheses and you have a square on the outside, that means everything inside there is squared, correct? All right. Now, whenever we just had a single term in there, it was all multiplication, we distributed that power to everything in the inside, correct? That only works if you have multiplication or division on the inside. Right now I have addition, so I can't just distribute the power. Okay, what a power on the outside of this guy means is this, a plus b times a plus b. So really it's a FOIL problem, right? Now if you ever have it in this form here where you have one thing plus one thing, quantity squared, you're going to end up with this, a squared plus 2ab plus b squared. Okay, so I'm going to show you how you can do this, kind of a shortcut. Square the first term, multiply the 2 together times 2, square the last term. So for instance, if I have this guy, let's go x plus 3, quantity squared. All right, so first I'm going to do it the long way. Then I'll do it by rule, okay? So first, I see this, I think, all right, I get a FOIL. So x plus 3 times x plus 3. All right, so then FOIL, x times x is x squared, x times 3 is 3x, multiply the 3 then, so 3 times x is 3x, 3 times 3 is 9, combine like terms, x squared plus 6x plus 9. What'd that take? 30 seconds, 40 seconds, something like that maybe? All right, let's do it again. Same problem. Now I'm going to go by rule. By rule says square the first term. First term's x. X squared. Multiplied 2 together. 3 times x is 3x. Times 2 is 6x. Square the last term. Here we go. It's what, 10 seconds? And that was even with me talking. So if you ever see one in this form, a term plus a term in the parentheses and the entire parentheses squared, you can use this rule. Square the first term, multiply the two together times 2, square the last term. But if you don't remember that rule, it doesn't matter. Just write it out and FOIL it. Okay? This is just one of those shortcuts if you want to use it. With me? All right. Now, in the second aspect, I'm going to show you the second shortcut, and then we're done. Right, Cam? You're trying to take a shortcut, too. Okay? This one is the difference of two binomials, two monomials squared. All right. What we'll find out later, this will be the difference of two squares, really. We just kind of trim the words. So if I have something like this, let's go x plus 3, x minus 3. Are they both the same terms? Both an x and a 3, right? One's a plus, one's a minus. Let's do it the one way. Let's do it the long way. So I multiply x times x squared. 3 times x is, oh sorry, I did the wrong order. X times negative 3 is negative 3x. 3 times x is 3x. 3 times negative 3 is negative 9. Okay? Combine like terms here and here. X squared minus 9. The ones in the middle just went to 0, right? Okay, so here's the rule then. If I have two terms, a plus b, a minus b, that's equal to a squared minus b squared. All right? So let's do this again by rule. Plus 3, x minus 3. Okay, one's a plus, one's a minus. It's the exact same terms, right? Square the first term. X squared is x. Square the second term. 3 squared is 9. Minus in between. Done. My two terms are x and 3, right? One's a plus, one's a minus. Okay, square the first term. X squared is x squared. Square the last term. 3 squared is 9. Put a minus sign in between. Take a walk. When you get back, start your homework.